Hello everyone, this is the video lecture for Calculus 1, section 2.8, derivatives of a function? Okay, I don't know. Derivative of a function. So, I'm going to say, just real quick, derivative in this particular section, there's a lot of definitions for derivative, is slope of the graph. Slope of the graph, okay? That's what I'm going to have to use. Yes, it's the slope of the tangent line and all that other stuff here. But slope of the graph, we're going to be focus on rising and falling. I'm going to give you some examples of what I'm saying here. But before I keep going, I'm going to say that this section, it's going to be fast because there's not much to talk about. There's not a ton of questions that I can see really, and a lot of them are multiple choice. You just click whatever. So I know you can get through it, but the concepts here are going to be one of the hardest because we're having to readjust our eyes to be able to see things that aren't there. And so I'm going to try my best to do this. If you're confused at the end of this about how and what's going on, you are not alone. I'm just warning you ahead of time. Try to hang out with me, okay? I'm going to do the best I can, of course, but a lot of these concepts are not something that I could just talk to you blue into the face and somehow it's going to work. It's something that you're going to have to investigate for yourself. It's something that you're going to have to see as you go through the homework and kind of conceptualize and eventually get on your own. That's the only way to learn. I can't actually learn for you. I can tell you, I could talk to you, but I can't actually imprint my concepts and thoughts into your brain. I can just talk, and you could just listen, and that's the best we can do. Okay, so here we go. We're going to focus on the rising and the falling of graphs. So here's an example of what I'm talking about. Let's say that I have this cool cubic. And you can see right here, we're rising, and then here, we're falling. A little bit of lag there. Then rising again. And so what that means is whenever you're on the graph, again, this is always left to right. Don't look at that. That should be back from college algebra days. Shouldn't have to talk about it, but that's okay. Don't look right there. Left to right. Okay, cool. When you're rising, that means you have a positive slope. And here, when you're falling, you have a negative slope. And again, when you're rising, you have a positive slope. Okay? So I want to graph the derivative slope here. So let's say that's f, and what they want is f prime graph. Go, figure it out. Well, that means I'm going to look right here. Positive, negative, and positive. And I'm going to be as crude and rough as possible. I'm going to put right here, this, you can see it basically goes to 0, and let's just call that 2 if that's okay. So at 0, it's a positive number up until that point, and then it's a negative number from 0 to 2, and then it's a positive number again after that. Now, I mean, this is the roughest graph that I've ever done for you, okay? I just said this is positive, this is negative, and this is positive. As far as a flat line or whatever, I don't even care. I don't know what numbers they are. I don't know. All I know is that I have a positive, a negative, and then a positive. And I just put little lines to kind of remind myself. Well, that's not going to do. That's not good enough. And so let's try to smooth it out a little bit. And so what I'm going to do instead now is I'm going to do positive, and then you see it hits the line now. Now it's going to be negative. So this is all negative territory. And then right here and onward, it's positive again. And that's again at 2. So I'm trying to smooth it out a little bit, okay? Something kind of like that. What's the average here? That's like that was an average, and now I'm going to try to make it, continuous, I guess. And this is all negative down here because it's below the x-axis, and then there we go. Well, this is still really rough, and we can do better than that. So if you kind of see, we have a cubic, and my answer is going to be a lesser degree. Can you kind of see it now? It's just a parabola. And I can't draw the best parabolas in the world here, but there we go. That's pretty good. Now, doesn't that look nice? Doesn't that look like something that we were wanting? That's your answer. That's your f prime. That's your derivative graph, I guess you could say. I don't know, something like that. Derivative graph. So notice that I had said the x cubed and then the x squared. That's, again, for the chapter 3 or difference quotient stuff. Maybe you kind of seen a little hinting of that as you continued on with the homework and whatnot. But these answers, the graphs that we're going to get, like these answers here, are legitimate graphs. They are actually like f of x equals something or other. They're not just going to be straight lines or flat lines or whatever. It's going to be a nice curve, you know? And so try the best you can to smooth them out, okay? As just a reminder, this right here, again, I'm taking my slopes and I'm changing them into y values. This right here is positive. I know you're thinking, well, it's going down. No, and I'm not looking at this guy. Stop. I'm saying right here, positive, negative, positive, negative. This is positive. This dude is negative. This guy's positive. And that's how I got it. Positive, negative, positive. Okay? I know. That's the big shift right there. That's it. If you got it, cool. If you didn't, I understand. Let's keep on going, okay? I'm going to do some more examples. And it's not easy. If you got it, cool. I'm happy. But that's the big shift. We just said it. Again, changing my slopes and the y values. Positive, negative, positive. All right. Here we go. So I got another graph here, and this is definitely not perfect. Something kind of like this, I think. And they want to know what the tangent line slopes are at, so f prime at -3. Oh, sorry. F prime at -2, all that kind of stuff. Da-da-da-da-da. And then we're going to graph it, basically. Now, I can't remember if they actually want this or not, but I'm going to certainly... Oh, I think they do want it. So what you're going to do is say, oh, -3 is like right over here, 1, 2, -3. And so right here, we want the tangent line. And I'm going to approximate that slope. I think maybe you can use the grid to kind of help you. The answer is in the -1. And then at -2, right here, it's supposed to be at the bottom there, so 2 right there. There you go. It's I've zoomed in a little bit. It's flat, so 0 is going to be the answer here. Here, kind of looking funky on my side. 0. And so on and so forth. You're just going to find all that. But notice that all these answers here, the next one's going to be a 0.5 and whatnot. These, again, are now your y values. Like what you're making is a table. -3, -2, -1. And then you got -1, 0, and 0.5. You're just going to make a table and connect the dots. So at -3, I got a -1. At 0, or at -2, I got a 0. At -1, I got a positive 0.5. And what happens is that this graph, when you connect all the dots, it does something kind of like this here. Something kind of like that. And that is your f prime graph. Those are actually slopes of the original. But again, I'm replacing my, these were slopes, but no longer. I'm going to change them into y values. Make a table, connect the dots. I didn't do the whole problem. It's true. Because guess what? There's a ton of these. So I want to change back to black here. Hold on. So these are going to be rapid fire for sure. And the best way to do it is I'm just going to talk about it the best I can and move on. Okay, so I'm going to find my from my f graph. So again, I just want to convert my slopes into y values. So the original looks kind of like this guy here. Okay, and again, mine's never going to be perfect, but there you go. And I want to convert this over. So this is my f, and they want f prime graph. So notice here that I am going to be rising and falling. So I'm falling, so that's going to be a negative number. And then at this point here, I'm now rising, so that's going to be a positive number. I'm falling again, a negative number, and I'm rising again, a positive number. And that's not good enough. We're going to, smooth it out. So, like, I'm going to try to connect these two. So they kind of do this, and then these guys connect, and then those guys connect. Something kind of like that. And if you draw it one more time more smoothly, looks like this. There you go. This was x to the fourth. Guess what this guy is? He's x cubed. That's right. That is my derivative stuff. This is f prime now. That's my answer, okay? I'm trying to make it as best I can. I'm never going to be able to do this perfectly. And so the best I can do is just show you and move on. Of course, if you have any questions, we can talk about it more. Just the recording, of course, is just the best I can do. Moving on. So this guy here is my original. Looks something kind of like this here. And so you can see that I'm rising. So that's going to be a positive. So I'm going to be positive all the way up here. And then I'm falling. So I'm going to be negative. But notice that as I get closer and closer out here, what's my slope? I'm not falling or rising much anymore, am I? It's zero slope. So eventually as I get out here, I'm going to have a zero value. See how, like literally, y value of 0. Somewhere over here. I don't really know. Somewhere over there. And so I'm starting positive, and then I go to negative, and then eventually I'm going to get towards 0. There you go. That's your f prime. Next one. 28005. So this one is funny. It does this kind of double way, whatever it is my f. And they say find f prime. Find my f prime graph. Well, here we go. I'm actually falling, and then I'm rising. I'm negative, and then I'm positive. So over here I'm negative, and over here I'm positive. But what about right here in the middle? What's my slope right there? Well, if you really zoomed in to right here, what's going on is it's like near vertical, and then it's going bloop, and then it just touches, and it barely comes right back up. So what's the slope right here? Straight up and down. What's the slope? Straight up and down, a vertical line. It's undefined, right? My slope is undefined. My slope is infinity. Yes, exactly. And so that's kind of weird. I'm saying that my slope is infinity. Therefore, my y value should be an infinity right here. Well, you can't get that. But what it's trying to indicate is a vertical asymptote. Because wouldn't I then take my graph here? This is negative. I'm somewhere down negative here. Oh, I wanted a different color. Hold on. Blue. So I'm negative. I'm somewhere down here negative. And couldn't I do this? Yeah, I know that's negative infinity, but what about this guy? He's positive. It's positive infinity. It's a vertical asymptote. That's what this is right here. That's a vertical asymptote. Because the slope, again, is basically straight up and down. Slope is undefined. That means it's going to be a vertical asymptote on my f prime graph. Whew, right? Whew. Okay, next one. 28008. So this one here is, I think it's a cube root, but it does this, and then it does this. Did you see something? Did you notice it? Look. It's straight up and down right there. That's undefined slope. And so therefore, that's pretty much a vertical asymptote somewhere there. But moving on, let's try the different colors here. So we have this right here is rising, so this will be a positive. And then this here is rising. It's positive. Well, isn't that weird? So my f prime graph, I'm going to have positive, and then I have a vertical asymptote right here, and then I have positive again. And again, we're really needing to smooth this thing out. So smoothing it out, it actually looks something like this. See how they're both positive. They're both on the quadrant 1 and 2, positive, positive, and then we have a vertical asymptote separating them. All right, that's all of those questions. All those rapid fire questions. Again, it takes a lot of time to get to this concept stuff. You just got to do it for yourself. You got to go through and maybe go through the book and see some more examples there. I'm just giving you the best I can. I know I've said that quite a few times. I'm going to stop saying it now. But there we go. If you don't completely understand, you're not alone. But let's keep moving. So, f of x is equal to mx plus b, and they say, what's my derivative equal to? Well, my derivative is my slope. So, what's my slope? Exactly. Like, that's your answer. You're done. And they say, oh, well, hold on. What's your domain of the f, of the original? What's your domain of a line? Negative infinity to positive infinity. Hey, what's your domain of f prime? What's your domain of this m right here? Well, m is just a number. I don't know, 2, -5, 7. And there's nothing wrong with that. Do you have any division? Do you have any square roots? Do you have like an ln? No. No, we're good. So everything's good. Negative infinity to positive infinity. All right. I've got 2 more problems. And one of them is a little bit longer. And then I got one that's really short. I want to do this next one here because it relates back to this stuff here in just a second. So this is the longer problem. And then we'll get to the short one, which will be real fast. I have g of x is equal to the square root of 6 minus x. And they say find g prime of x. Oh, yes, this is good. Look, we're using x now. Yay! All right, so no more A's, though on your quiz and on your exam, expect to have an A in there once in a while. I've seen it. I've seen people get it wrong, and I've seen myself giving full credit for it because it's just annoying. But now, finally, we get to use X, and that's a good thing. So let me just give you that formula one more time, and then we're going to go through this huge thing. So the limit is h goes to 0 of f of x plus h minus f of x, all divided by h. That's your formula. So let's do it. So again, remember that this x plus h, I'm going to be replacing this x right here with that. So it would end up being a negative x and a negative h whenever you distribute the negative. Be very careful about that. All right, so here we go. G prime is equal to the limit as h goes to 0 of, here we go, the square root of 6 minus x, and then minus h, sorry. All right, minus the square root of 6 minus x, all divided by h. X, h, 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 x, x, h, h, x. All right, go ahead and plug in a 0, right? Nah, it's not going to work. So what do? We've done this before in the last section. You multiply by the conjugate of the square roots, in particular, the numerator. So that'll be a plus sign here in between them. And again, the same in both the top and the bottom. The reason why I'm doing that is because when I start foiling, the square roots are all going to cancel. And so then I've got the original 6 minus x minus h, and then minus the original 6 minus x. All the other stuff cancels. If you want to see more detail about how that works, that was one of the last questions of the last section. Okay. And this 6 here and this 6 are going to cancel, again, because I'm distributing the negative. I got my x and my x are going to cancel, again, negative and positive, leaving this h here. And that's a negative h. You already know what's going to happen. I'm going to cancel my h's. Remember to make that a -1, okay? And now I can finally apply this limit. Well, that was, 0, right? Notice that I was not writing that every single time. It's good to write limit just as a reminder, but do you have to do every single little piece every single time? No, you do not. And with me, because I guess I'm your teacher here, I'm going to definitely leave off some notation once in a while, just because it's faster, and I want to train you in the fact that we can remember some of this stuff. Now, I don't want you to forget it, but I mean, that was a pretty obvious thing, okay? So I'm just making a point, as you move on in more math, you don't have to do every single little thing as long as you're remembering what you're actually doing, okay? And you'll get better at remembering as we go. Plugging in the 0, well, there's nothing over there to plug in. So plugging in the 0, we get the square root of 6 minus x plus the square root of 6 minus x. Yep. And there's 2 of them. And I'm just going to say, so here, I don't want to be confusing. There's 2 of them, so then we have it looking like this here. And that's it. You're done. Now, could you have done this with the chapter 3 concepts and formulas and stuff that we're going to have? Yes. Will it be easier? Yes. But still, this is not that easy. It still would take a little bit of time, so I'm glad we did it together. What's the domain of f? Now, this is actually important. So let me go back up to this guy right here. What's the domain of the original? So let me just pause and ask you some questions. Do we have division? No. Do we have a square root? Oh, yeah, we do. So whenever you have a square root, you want to know, when is the inside equal to 0? And so you say 6 minus x is equal to 0. X equals 6. And that's actually a start point. And so my actual, well, or an end point, sorry, is actually an end point in this particular case because it's a negative x. Whatever. This is college algebra stuff, so I'm going to assume that you kind of get it a little bit. But 6 is your important number, and we're going to go all the way up until 6. And so my domain is going to be the negative infinity all the way to 6, and then a square brace. Square root, square brace. Okay. Again, generally we have this one, but because they had a negative x on the inside, we don't do this, we do that style instead, okay? All right, now, what's the domain of f prime? Again, this is my f prime right here. There it is, my derivative, f prime of x, I guess. Again, see, that's me leaving off notation. Isn't it technically just f prime of x? Yeah, it's whatever, it's f prime, it's fine. So what's your derivative of this guy? And let me ask you the same questions. Do we have division? And yes, we do actually. We have a division, so I have to know when the bottom is equal to 0. And we'll do that here in a second. Okay. Do we have a square root? Yes, we do. So I need to know when the inside is equal to 0. What actually happens, and this is the funny little case, is that when the inside is equal to 0, then the entire bottom will end up being 0. So it's the same number. And it's the same number that you had just a second ago. It's the 6. 6 is, I guess you could say it's a start point. Oh, wait, never mind. It's an end point. But it's also when the bottom equals 0, which makes it a vertical asymptote. So it's both an end point and a vertical asymptote. My default answer would be go back to this guy, because, I mean, they're the same. But it's not this one because I can no longer use the 6. He's now in the denominator. This right here is actually a pretty cool thing, and we will certainly be seeing this again in Calculus 2 when it comes to the infinite series stuff and whatnot, trying to find domains and not just domains, but also solving for x values and all kind of stuff. I can't remember all the terms right now, but definitely it will come up again. So this is pretty cool stuff. I'm going to move on. So 28041, I have here. Differentiable. Is when a graph is smooth and continuous. Smooth and continuous. That is my default answer. And so something kind of like this. Okay. Something kind of like this here. See how they're smooth and continuous. But what if you go... Okay, see how they're sharp corners? That's not good. Okay, here's another one. Zero. Sound effects included. Notice that it's not continuous, so that's not good. So differentiable means smooth and continuous, but that's the rough definition, I guess you could say. Also, what does it mean to be differentiable is that you can take a derivative. You can take a derivative, or you can find the slope within those particular domains and stuff like that. You can always take a derivative of even just like a piece. Like here, you can take a derivative from there to there, or from here to here. That's okay. But like generally for the entire function, that's what we're kind of asking about, okay? So can you take a derivative of it? And so this particular graph that they're going to be showing you, it has a sharp corner, and then it comes down, and then there's a solid, I believe, right there, and then there's a circle here, and then it comes down like this, and then it goes out like that. And it says, where is it not differentiable? Not differentiable. Where can I not find the slope? Well, right here is an obvious point. So like we're sitting at the very top of a mountain and like a board is teetering on it, and like, I don't know, what's the slope? Just kind of put that in, in your mind, I guess. Like you have a little pivot and it's like a seesaw, and that seesaw could go all over the place. You can't have any one slope. So right here, that's a problem. Notice that we have this jump discontinuity. So that's definitely a problem as well. So we got to label that here in just a second. And then this guy. Notice that it's straight up and down. And again, what's my slope is undefined, isn't it? But yet it's still smooth and continuous right there. So what I'm going to say is that my first definition is not perfect. I'm going to add and like, ooh, let me just start over. And non-vertical. I had to add a little bit more to my general definition because this guy, obviously, we have a slope straight up and down. We had already talked about that in previous problems where that means that it's like an infinite slope, and therefore you can't do it. So this one here ends up being at -4, by the way. This is obviously at 0, and this guy here is at 2. And so your answers are just the x values where you have problems, okay? Just the x values where you have problems. And that's it. We're done with all of Chapter 2 now. Doesn't that feel awesome? So, thank you very much, and have a great